Imagine this as a single cell.
It is like a cell in a fluid environment, just like in our bodies.
Ideally, the solution outside the cell has the same concentration of dissolved molecules or solutes as inside. The solutions are called isotonic.
Iso means equal, and tonic?
It stands for concentration. In isotonic conditions, the movement of water into the cell is balanced by the movement of water out of the cell. The cell is in equilibrium with its environment.
But what if the solutions inside and outside the cell are not isotonic?
The cytoplasm in the root hair cells of this plant have a higher concentration of dissolved molecules than the water in the soil around them. So the solution in the root hair cells is called hypertonic because it has a higher or hyper concentration of solutes and fewer water molecules. On the other hand, the soil water is hypotonic because it has a lower or hypo concentration of dissolved molecules and more water molecules. By osmosis, water molecules move from the hypotonic solution in the soil into the hypertonic solution in the root cells. The solutions try to balance their concentrations of solutes and water.
But this is salt water. What if we add it to the soil of this plant?
You'll increase the concentration of dissolved molecules, in this case salt, in the soil water.
The soil water is now hypertonic compared to the plant cells. And look what happens.
By osmosis, the water follows its concentration gradient out of the plant cells, through its roots, and into the soil. The cells shrink, and the plant wilts.
In normal conditions, the cytoplasm inside a plant cell exerts a force called turgor pressure against the cell walls. This gives the plant support and rigidity. Plant cells in a hypertonic environment lose water due to osmosis. The cytoplasm shrinks away from the cell walls. It's called plasmolysis. The loss of pressure against the sides of the cell walls causes the plant to wilt.
Now, can we reverse the effects of plasmolysis?
If we put water back into the soil, it'll return to its hypotonic state, making the soil water less concentrated.
By osmosis, water will move back into the plant cells and help restore turgor pressure to support the plant.
It's called deplasmolysis.
But don't leave it too late.
So cells that are placed in hypertonic solutions or hypotonic solutions are not at equilibrium. But water always moves towards equilibrium by osmosis, creating equal concentrations or isotonic solutions.